Good afternoon, sir. Good afternoon, sir.
Okay, good afternoon, cadets. Am I audible?
Yes, sir. Good afternoon.
Okay. Thanks a lot once again. A very good afternoon to each one of you. Okay, little changes that I have done on my side is that, as I told you yesterday, I conducted the lecture yesterday from TMI from faculty area. So there was a lot of disturbance because other faculty members were speaking or they were conducting their own lectures. So I have shifted myself into MBCL 10, main building classroom number 10. And I think I am quite audible now without any disturbance. Is there any disturbance now?
Not yet, sir.
Not yet. Okay, okay. Right. I see a very humble attendance right now. Only 29 are present. Suppose should have been 35, including myself. Okay. Is any, I mean, you all are sitting in your own room, right?
Yes, sir.
Okay, because yesterday I had a lecture on division 5 and 6, and because they were in quarantine and the network was not good, so like they were sitting together and some 5 or 6 cadets were like huddled in a room, right? So that is not the case in our case, right? So let's begin. Right? So I will keep on referring to this particular syllabus. I will keep on referring to this syllabus, and it's what we have done so far. And I will keep on taking, okay, these are the things that we have done. I think lecture number 1 or lecture number 2, I showed you the syllabus. The syllabus is divided into 2 parts. One will be done by myself and other will be done by Mali madam. So DC part will be done by Mali madam. The AC part will be done by me, and the instruments that also will be covered by me. So what we have done so far, if I'm not mistaken, so we have started with this alternating current. Explain how alternating current is produced in a simple loop rotating in magnetic field. Have you done this? Can I take this? You have seen a video yesterday in which the animation was shown, in which the coil was rotated in a magnetic field and how we saw the direction of the current reversed every half cycle. Okay. Can somebody tell me which law was used there?
Right and Fleming's too.
Very good. Fleming's right hand rule was used over there. Do we remember what does the 3 fingers do they represent? So Fleming's right hand rule, absolutely correct. Please help yourself or please help me. The first finger is, let us say, thumb.
So force.
Force.
Thumb is for motion. Please remember.
Magnetic field.
Magnetic field, first finger.
Okay, first finger or fourth finger.
And
So yeah, very good.
And middle finger current.
Very good. Okay, so first and F. Okay, so this is very simple way to remember as it was taught to be by my faculty members some 40 odd years ago. So first and fourth, they go hand in hand. Okay, and the remaining third will be the middle finger. That will be the direction of current. Please do it. I know that you are not being provided with notebooks, but I'm sure that you have got certain things on which you are going to make the notes, right? So please write down this because these words we look for when we check your answer sheets. Okay. So the Fleming's right hand rule was used over there for determining the direction of current, and as the coil completed the 180 degrees revolution, the direction of current automatically reversed because the motion was from clockwise to anti-clockwise, and therefore the direction of current reversed. Okay. Relate the position of the loop. So I'm reading out this. So relate the position of the loop above objective to the voltage waveform for one cycle at 90 degrees interval by means of sketch. Okay, so this was also done over there in the video itself, right? So in the video, how we saw like at 90 degrees, the voltage was maximum, and then at 180 degrees, the voltage becomes zero. Then at minus 27 or 270 degrees, it became negative maximum, so on and so forth. Okay. So we have done so this so far. Let's move on. Okay. Now we will be doing this small derivation. So we will be doing this derivation, develop the expression to produce E is equal to E max sine theta, where E is the instantaneous voltage, E max is the maximum voltage, and theta is the displaced angle. Right? So very small derivation that we will be doing. Okay. Right. So please allow me. So as you can see over here, what has been done is that what you see over here is the so-called coil. So this is a so-called coil which has got n number of turns. Okay. This coil is rotating in the anti-clockwise direction. What is the angular frequency? I just highlighted that.
Omega.
Omega. Okay, very good. And we have what we have done is that we have marked the position of the coil after time t. So therefore, this becomes angle theta, which is nothing but omega times t. Omega is angular velocity. So the coil has been displaced after some time, and the position has been marked over here. Okay, and so therefore, the coil is making an angle of theta with respect to x-axis when the displacement was after 60 seconds. Okay. Now these are the flux lines. Yesterday we saw there was a permanent magnet in the concave shape which was placed. So from north pole to south pole, these are the flux lines, and phi m indicates the maximum flux line. Okay. Now we want to find out what we have done over here, that we have considered a rectangular coil having 8 turns rotating in uniform magnetic field with angular velocity omega. So I'll just write down what we have considered so far. Coil having 8 turns. Number 1, rotating in from magnetic field. Okay. Angular velocity is omega. So in time t, the coil rotates. In time t, the coil rotates to an angle theta.
Maybe, sir,
Yes.
what is the
difficult to erase.
Okay. That is another problem with this particular mode of teaching. When I'm teaching and when I'm writing, my voice automatically becomes low. Okay, thank you very much. I'll take care that my voice does not drop down. Thank you very much. So in time t, the coil rotates, okay, through an angle. So that angle, so through an angle theta, to an angle theta, which is nothing but equal to omega t. Okay, as marked over here, theta is equal to omega t. In the deflected position, the component of flux which is perpendicular to the plane of coil. In the deflected position, we want to find out this component. We want to find out this component which is perpendicular to the coil. Okay. Now tell me one thing. Suppose I have been given a vector. Okay, so let us do this quickly because you. So this was a vector. It is an angle theta. So this vector, it is an angle theta. This is the magnitude, let us say r, and this is angle theta. Okay. Now there is something called as resolving of the vectors. Now suppose if you have to add two vectors, normally what we do is that suppose I had these two vectors and I've been asked to add them. Right. So one method is that what do I do is that I complete the parallelogram. Right? And I complete the parallelogram, and this becomes my resultant. Right? So this is one way of finding out the resultant. Another way is that which will be taught to you. Another way is that which will be taught to you is that we resolve the vector. So let us say this was my vector. Now I will do something called as resolving the vector. So that means I will find out something called as its real component and imaginary component. Now this will be done in applied mechanics. Okay, can you tell me how much will be this? I know the hypotenuse or I know the diagonal and I know the angle. So can you tell me how much is this? As well as, can you tell me how much is use R and the angle and sine and cos, some relationship. Simple thing, use basic trigonometry. The angle is known to us.
R sin theta.
Sin theta.
Very good, very good. Who is R sine theta?
Question mark.
Okay, the one which is question mark. Okay. Right, so absolutely correct. This one is R sine theta. Right, so this is something called as vertical component, and the horizontal component will be equal to R cos theta. Okay. Now same concept has been extended over here. Same concept was extended over here.
So what is that phi m?
Please come again.
So what is that phi m?
Okay, phi m. Okay. Now please remember that this phi is something called as flux. Phi stands for flux. and phi m stands for flux maximum, right?
Okay, sir.
Now, what we are trying to do over here in this derivation is that we are trying to find out how much is the flux which is linked, how much is the flux which is linked with the coil when it is rotated by angle theta. So we must find out. So this is the flux phi. Now the coil is not in line with the your lines of flux. So we want to find out this particular component of the flux phi. Okay. Now this is angle theta, as you can see over here. So as we just did over here, when we resolve, the horizontal component came out to be r theta. So therefore, the horizontal component over here will also come out to be r cos theta. So on the same line, this is angle theta. The diagonal is phi m. So therefore, the horizontal component will be equal to phi m cos theta. Right? So if this is okay, please type into the chat box okay, so that we can continue further. Okay. Wonderful. If this is understood, then rest of the derivation is extremely simple. So we are about to derive what is the we are about to derive the equation for the voltage which will be induced into the coil because of this because of its angular moment. Okay. Write down what we just found out. So what we have found out is that in the deflected position, the component of flux which is perpendicular plane of coil Okay, so that is what we have just found out. Okay. So therefore that is given by so that is given by phi, which is equal to phi m cos theta. Great. Which also can be written as what is theta? Theta is nothing but omega t. So phi is equal to phi m cos omega t. Okay. Now, because there are n number of turns, so flux linked at any time n into phi m, n into phi m, bring down the derivation. Okay. Because this is asked in the, this will be asked in the exam. Law of electromagnetic induction.
Throwing the
एंड कर दे भाई.
भाई तुम लोगों को आवाज आ रही थी क्या?
End the meeting.
अरे
नहीं
तुम
नहीं नहीं
तुम
आ
लोग
रही
को आवाज आ रही थी?
नहीं आ रही होना सर.
समझ में भी नहीं आ रहा, पता नहीं क्या पढ़ा रहे हैं भाई.
सही बात है
के
भाई,
चक्कर में.
सब ऊपर से जा
Jatin 084, can you?
Yes, sir. Yes, sir.
Okay, make me host.
So I made it the host, sir.
The trouble is that whatever I have done. I have done something over here, so I will just write down those equations, the derivation part, etc. We have done. Okay. So we were saying that according to Faraday's law of electro.
Sir, your voice is not clear.
Your network is unstable.
Hello, can you hear me?
No, sir.
Am I audible now? Audible?
Sir, you are
Not
not
clearly,
audible.
sir. Not clearly, sir.
So
Am I
your voice
audible
is
now
lagging.
or still voice lagging or
Voice
is
is
it
lagging.
very
Sir, your voice is
The
lagging.
voice is
low?
lagging.
Sir,
Sir,
not
your
audible.
voice is lagging too much. Yes, sir.
Is it still same? Is it lagging or now is it okay?
Yes, sir, lagging.
Is it lagging or is it okay?
Sir, still lagging.
Because when I hear your voice, it also lags. What I will do is that I will log out, I will log in. Right, I will log out and I will log in. I will make somebody host. Right, when I will log in once again. Okay. The first person that I see is Dhruv Kakade, 088. Are you there, Dhruv?
Yes, sir. I'm here.
Okay. No, still I am host.
Sir, your voice is not coming.
Sorry.
सर की आवाज आ रही है?
Sir, आपकी आवाज नहीं आ रही है
नहीं आ
actually.
रही आवाज.
यार सर की आवाज आ रही है
You
किसी
can
को?
see that.
नहीं आ रही नहीं आ रही.
Hang on. Abhishek is now host 042. Abhishek, you're
Yes, sir, I made.
okay. Is the voice still lagging or is it okay now?
Sir, it's still lagging.
Okay. Abhishek, I will make you host, leave, and I will re-log in. Abhishek 042.
Yes, sir.
Okay, am I audible now? Am I audible? Yes. Thank you, Abhishek. Okay. Please tell me, am I audible so that I can continue?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Okay. Thank you very much. Again, my apologies on behalf of Zoom, right? So this is what we were doing before we got interrupted. So let us continue as we were doing the derivation, and the derivation is very much part and parcel of the syllabus as well as can be asked in the examination. So what we have done so far is that we did this, we have derived n phi is equal to phi m into cos either theta or n into phi m into cos omega t. Can somebody tell me?
Sir, your voice is lagging again. You are not audible.
Is it still lagging? Because
Yes, sir. I think it's your internet issue.
I am sitting in this year 10 and I have got very good internet as far as this thing is concerned. Is it still lagging?
The voice is not lagging. It's low. Voice is low.
Okay,
So
if
when
it
you
is
see something, it lags.
Sir, the video
No,
is
sir,
moving
it's
forward
lag.
and the voice is lagging behind.
Yes, sir. Then, sir, I think it might be a hostel's internet issue.
I think so because when you speak, then also your voice is also lagging. Okay, is it still lagging or is it okay now?
Yes, sir, it is okay now.
Let's see what best we can do. Over here, the phi stands for the magnetic flux. We have got the magnetic syllabus. So magnetic circuits will be done by Male madam. So just everybody has done the magnetic experiment, right? So when we place the magnet and when we place something like, iron dust, the iron dust will get augmented in a peculiar manner. And those can be thought of the lines of force of a magnetic field. So the flux, phi stands for flux, which is nothing but the magnetic flux lines. Okay. So therefore, what we have done so far is that we have derived this. Okay. N into phi can be written as n into phi m in theta, or can also be written as n into phi m into cos of omega t. Okay. Let us continue with the derivation because something hits us. Okay. So according to Faraday's law of induction, according to Faraday's law of induction, the EMF which will be induced into the coil, right? Now, please understood that the coil is rotating into the magnetic field. So therefore, there will be EMF which will be induced into the coil, and that EMF is proportional to the rate of change of flux linkage. Okay. So according to Faraday's law of induction, EMF induced is proportional to the rate of change of flux linkage. So therefore the induced EMF that is electromotive force will be given by so the induced EMF is given by E is equal to minus. Why minus? Because the EMF which is developed into the coil opposes the cause. So therefore negative sign d by dt okay into n phi. Right? So according to Faraday's laws of induction, EMF induced is proportional to the rate of change of flux linkage. So E is equal to minus d by dt n into phi. So let us put for phi. So it will be equal to d by dt therefore phi we can put n into phi m and cos omega t. Now by by differentiating, I'll have minus. Now all the constant terms they will come out common. N being number of turns, so constant. Phi n magnetic flux is also constant, so will come out outside. Then omega angular velocity is also constant, right? So therefore it will be out, and the differentiation of become plus, and the expression can be written as omega into n into phi m times sine theta or sine omega t, one and the same thing. Now here we define something called as EM, the maximum value of induced EMF. Am I audible now? Perfect. No lag.
The lag is there, sir.
It's still lagging.
Okay, but I hope you are able to follow what we are trying to. EM is nothing but this whole bracket will be EM. So EM will be equal to omega n into phi m which will be nothing but equal to. Now omega can be written as 2 into pi into f. I hope you all know about this conversion. Into PM.
So you are not audible.
Times A. So where B is equal to BM. Hello.
Sir, please repeat the last step, sir. Your voice was not audible at that time.
Okay, am I audible now?
Sir, you are sometimes and sometimes you are not, sir. That it is not constant or something.
I know that it is the internet that has to be blamed. Okay. I hope
So
I'm
can you repeat
audible
the last
now.
step where you written EM, omega, and phi in one side?
This whole thing is a constant. Okay. So this whole thing is a constant, and that gives the maximum magnitude of induced EMF, right? So omega n into phi m has been put up as induced EMF. So therefore E, that is EMF capital E with suffix m. So this has been equated with this maximum value. Now Bm is nothing but maximum flux density and the unit is Weber per meter square. Next thing is A is area of cross section. Area of coil. Meter square. And last but not least, F is equal to frequency of rotation. So therefore, this equation can be rewritten as E is equal to En sin theta or Em sin omega t or is this clear? Is the derivation clear?
Sir,
Yes, please go ahead.
sir, above we have written EM equals to 2 pi f and BMA. Sir, ये BMA कहाँ से आया?
Not clear. Please speak.
Sir, I am saying that
Slowly.
after you written
EM is equal
omega
to-
n phi m, from where did BMA come from? The in 2 pi f and BMA.
Okay, 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 okay.
सर मीटिंग छोड़ के चले गए।
CR सर को बोलो एंड करे क्लास।
बड़ा डाउट है मेरे को।
Hello, hello, am I audible?
यस सर।
Okay, Abhishek, you are the host. Please make me host.
Done, sir.
Yeah, thank you very much. Okay, real horrible experience from not from your side, but from Zoom. Okay, I was so much looking forward to the lecture. Am I audible now?
Yes,
Still-
yes.
यस सर।
Okay, and I was actually looking forward to this lecture. What I will do is that this PPT was also with me. Just give me a minute. I'm trying to open up that PPT. Okay, I will see what I can do about the thing because this derivation is also important because it has been stated into the syllabus says that we have to do this derivation. Develop the expression E is equal to BLV to produce E is equal to E max sine theta, where E is the instantaneous voltage, E max is the maximum voltage, and theta is the displaced angle. Right. So this is what I was trying to do. I will see what I can do. I mean, today's experience, nobody to be blamed, but it was really horrible. See, the thing is that we are sitting, maybe about 1 kilometer away, and we have to rely on the technology that too also is not holding our hand. Right? God only knows. This is really, really counterproductive. Right? Believe me, this derivation used to take about 5 or 10 minutes in the class, and after that, I used to go to something called as how this can be project the vertical component. So how this thing can be thought of as a vector. Okay. We have what about, am I audible now or is the voice still lagging?
No, sir, you are audible.
I think there is some issue at the hostel because if anybody is speaking, right, your voice is lagging and I get a echo kind of thing. Okay, somebody else try and speak.
Sir, you are audible clearly.
Okay, thank you very much. See, now it is only last 15 minutes and now I am audible. Okay, I will see what I can do in the next lecture about this particular derivation because it has been clearly stated that it has to be done. So develop the expression E is equal to E max sine theta. So I tried doing that. Let's see what we can do about it in the next lecture. I just speak about this project, the vertical components of the rotating vector to draw one complete cycle of the sine wave. Okay, so please allow me, and then I will stop. Yesterday, in fact, we spoke about this, that the instantaneous, the sinusoidal wave can be thought of as a vector. So I will speak about that and then probably we will stop. Is the screen visible?
Yes, sir.
Okay. Now what you can do is that, let us say, we have taken a vector of some magnitude. That magnitude has been called as EM. we thought that we are rotating the vector in the anti-clockwise direction. Okay, we are rotating the vector in anti-clockwise direction and at some positions. Okay, let us say at say 30 degrees, 60 degrees, 90 degrees. Likewise, we divide this circle. Okay, then on this axis, okay, we depict one complete cycle, and we can take any scale, right? So it has been divided into 1, 2, 3, and 4. Okay, so this has been divided into 4 equal interval for half cycle and 4 interval for another half cycle. What you can do is that I will tell you how this waveform has
Sir, your
come.
voice is lagging.
Okay, okay. Let's end the lecture, guys. Let's end the lecture, and I'm not what you can say, angry with you, but I am extremely annoyed. Pissed off is a proper word, probably. Okay. Is anybody absent by any chance? Because I see only 35 present.
So all are present.
All are present.
Sir, 34 is the strength.
Sorry. Yeah, division 2. 34 is the strength and 35 all are present. Okay. So, Cadet, again, my apologies. I was actually very fondly looking forward to this lecture. You know, I had thought that I will do something like this and I will do something like that, but it's not happening. Okay. Right. Thank you, guys. Thank you very much. Jai Hind.
Sir, excuse me, sir.
Can you take offline classes?
Sir, can you take offline classes for important things, sir? As it will be easy for us to understand.
See, I will try to do something like that, but right now, I do not know how to do that because I come in the institute and we have been forced to take classes like this. Okay, we will find out some means. Don't worry.
Yes, sir. Thank you, sir.
Sir, when will you get the textbook?
Textbook and notebooks you should get in a week or so.
Okay.
Okay. Yeah. Thank you, guys. Thank you very much. Jai Hind. Okay, I don't think. Okay. Devish 056.
Yes, sir. Should I end the meeting?
Yeah,
or make
please,
it the
please.
host?
Yeah, please end the meeting.
Okay,
Thank
sir.
you.
Thank you so much.
God bless you all.
देविश मत कर एंड मैम आ जाएंगी इसी में ही.
नहीं कर रहा.
No, lecture is at 3 o'clock. We have got still 10 more minutes. So just end the lecture and let ma'am become host.
Okay, ma'am. Okay, sir.
Yeah. Thank you.
equation.
Recording in progress.
Okay. And then if you solve this algebraic equation, you are getting some solution. Okay. And then if you apply inverse Laplace transform, then you are getting your answer in time domain. Okay. So this is the use of Laplace transform. Abhi nahi samajh mein aayega? Okay. Now, if I ask you, मेरे पास एक mathematical device है, and if I ask you कि using that mathematical device, in which function LIATE किस फंक्शन में मैं उसे कन्वर्ट करूं तो वो बहुत इजी हो जाएगा, मुझे आगे उसका काम करना इजी हो जाएगा. लॉगरिदमिक, इनवर्स, एल्जेब्रिक, ट्रिगोनोमेट्री या एक्सपोनेंशियल, बताइए. I have a mathematical algebraic. Very good. ठीक है ना? So algebraic में अगर हम convert करते हैं तो it become very easy to solve. So this Laplace transform is a function which converts is a transformation which converts the function into algebraic function. Okay. Now, it is applicable to which function? Continuous function, piecewise continuous function, step function, impulse function, periodic function. Okay. And it has many applications in mathematics, physics, optics. जब आप BEE पढ़ोगे ना, BEE third year में इलेक्ट्रॉनिक्स का कोई भी सब्जेक्ट पढ़ोगे ना, in that Laplace transform का मैडम यूज करवाएगी, सुजाता मैडम will use this Laplace transform. Control engineering, signal processing, okay? तो इलेक्ट्रिकल इंजीनियरिंग में Laplace transform का मैक्सिमम यूज होता है. Okay, it is a very versatile tool to the engineer and scientist, ठीक है? Because it gives a very simple solution. Okay. Now, the notation for this Laplace transform is capital L. Laplace of any function ft is nothing but function of s. This f bar of s is also denoted as capital Fs. Capital letter Fs, function in S. If you apply Laplace on any function ft, and it will be converted into function in S, where S is a parameter. Okay, this may be a real number or complex number. कुछ भी हो सकता है. When I use parameter, this word, ठीक है? Parameter का मतलब है sometimes it is treated as constant, sometimes it is treated as variable also. Okay. Now what is the definition of Laplace transform? तो कहते हैं कि Laplace of ft means ft must be कैसा function होना चाहिए? It's a function of t defined for all positive values of t. Then if I want to find the Laplace of ft, then it is nothing but integration from 0 to infinity e raised to minus st ft dt. If you integrate within the limit 0 to infinity, you will be getting some function in a form of s. S के form में आपका answer आएगा. What is the definition? Okay, definition starts from 0 to infinity. Means Laplace transform is also there for minus infinity to infinity limit के लिए भी है. Minus infinity to infinity. Definition is same. Okay. So this type of Laplace transform is known as dual Laplace transform. But here हम dual Laplace transform पे काम नहीं कर रहे हैं, हम हमारा simple Laplace transform है उस पे काम करेंगे. So Laplace transform, when this word is used, then it is nothing but this e raised to minus st ft dt. Definition: by heart होनी चाहिए. If I want to find Laplace for any function, then I'm going to use this definition and will get my answer. What is the sufficient condition for this existence of Laplace transform? So it says that ft, Laplace transform of this function exists for s greater than a, if function must be continuous and its limit from t tends to infinity must be finite. This is the sufficient condition for existence of Laplace. Okay, now I'll explain you how to find the Laplace for some basic functions. Laplace for some basic functions. When I say,
मामी एक सेकंड हल्का सा पीछे कर दो.
स्क्रीनशॉट ले रहा है क्या? पूरा पीडीएफ
नोट कर रहा था.
पूरा पीडीएफ देने वाली हूं मैं, यही देने वाली हूँ. ये टाइप किया हुआ है सब कुछ.
अब अभी साथ साथ हो जाता है ना, फिर बाद में नहीं हो पाता.
अच्छा ठीक है, गुड, चलेगा. Okay, so today we will see some of the Laplace transform of some of the basic functions. Okay, so if I ask you what is the definition of Laplace function ft, so your answer must be integration from 0 to infinity e raised to minus st ft dt. E raised to minus st ft dt. This is the definition of Laplace transform. इसी पे बेस पूरा चैप्टर है. Now, अगर मुझे ऐसा बोला, I want to find Laplace for, say, a function x, not x. It is a function in t. Say t. Then how should I write this definition? कौन बताएगा मुझे? How should I write this definition? What is your definition of Laplace of ft? आपको फंक्शन दिया है ft is equal to t. Now I want to write like this. मुझे ऐसा लिखना है. कैसे लिखेंगे बताओ? Who will tell me?
Ma'am, 0 to infinity. E to the power minus st t dt.
T dt. Very good. क्या रिप्लेस किया आपने? फंक्शन है ft, जहां
ft की जगह t रिपीट कर दिया.
बस. अब इसका आपको इंटीग्रेशन पता है, इंटीग्रेशन बाय पार्ट्स, and you will get your answer, right? Suppose I want to write like this: Laplace of sine.
Yes, ma'am.
2t. Laplace of sine 2t. How to write? Come on, jaldi jaldi.
0 to infinity e power minus st sine 2t into dt.
Very good. Suppose I want to write Laplace of e raised to at. Bolo.
Integral 0 to infinity e power s minus st again into e power at dt.
Very good. So understood? So
Yes,
this is the way you can write the Laplace. If this is given, ऐसा लिखा है, तो आप ऐसे लिख सकते हो?
Yes, ma'am.
Oh, you can. Huh? Suppose if I ask you integration from 0 to infinity e raised to minus st and t raised to n dt. ये किसकी definition है?
L of t raised to n.
L of t raised to n.
Easy है? Yes. है ना? So this is the way you can understand. So e raised to minus st के अलावा जो भी term है उसका ये Laplace है. Okay. Now, so once you have understood all these things, I want to find Laplace of 1. ये मेरा एक basic function है 1. Constant है. My function ft is क्या दिया है? 1.
1.
ये जो भी लिखा है सही लिखा है? Is it fine? Huh? By definition of Laplace, write down the definition and then find Laplace of ft. आपको दिया है 1. So wherever there is ft, write down 1. Then integrate it. तो इंटीग्रेशन मेरा बना e raised to minus st upon minus s. सही किया है ये इंटीग्रेशन? Yes or no?
Yes, ma'am.
E raised to minus st upon minus s between the limit 0 to infinity. माइनस s ये क्या है? कांस्टेंट है, पैरामीटर है, उसे साइड पे रख सकते हो आप. You can take a side पे ले लो उसे. And then apply the limit on e raised to minus st. You are substituting the limit for t, not for s. You are substituting the limit for t, not for s. s के लिए नहीं, s तो आपका पैरामीटर है ना? t is a variable over here. You are taking derivative with respect to t. तो t की जगह पे आप ये लिमिट रखोगे. So e raised to minus s into infinity will give you e raised to minus infinity. And e raised to minus infinity is 1 upon e raised to infinity. And 1 upon e raised to infinity is 1 upon infinity. And 1 upon infinity is what? 0. है ना? Okay. तो ये बन गया 0. Minus e raised to 0 is minus 1. Yes or no?
Yes.
तो क्या बन गया आंसर? What are you getting your answer? Yellow highlighted.
1 by
1 upon s is what? It is a function in s. है ना? Fine. Understood. So if I ask you what is Laplace of 1, तो आप क्या जवाब दोगे मुझे?
1 by s.
1 by s. What is Laplace of 2? 2 by s.
Ma'am, 2 by s.
What is Laplace of some k function, constant function?
K by s.
K by
K
S.
by
K
s.
by s.
हाँ. Understood? हाँ. तो ये आपका फर्स्ट फॉर्मूला है.
ma'am.
Laplace of 1 is 1 by s.
Excuse me, ma'am.
Yes.
मैम एक बार ये बता दो s क्या रिप्रेजेंट कर रहे हैं?
पैरामीटर है वो, पैरामीटर.
मतलब
You
कोई
may have,
पैरामीटर.
या यू में है ये s का वैल्यू रियल भी होता है, कॉम्प्लेक्स भी होता है. कॉम्प्लेक्स नंबर भी हो सकता है, रियल है वो.
ओके मैम.
ओके, एंड कॉम्प्लेक्स भी हो सकता है. ओके, सो अगर ये वैल्यू सपोज रियल लिया मैंने, तो ये मेरा एल्जेब्रिक टर्म बन गया या नहीं? एल्जेब्रिक टर्म बन जाएगा ना ये.
यस मैम.
दिस इज इन टर्म ऑफ s के टर्म में फंक्शन है. चलिए, नाउ सेम लाइक दिस I want to find Laplace for e raised to at. Laplace for e raised to at. ये चाहिए मुझे. So same again, by definition of Laplace, I'll write the definition. Ft e raised to minus st ft dt. What is my ft? E raised to at. Substitute karo in place of ft, e raised to at. Anybody can tell me why I have taken out minus sign over here? क्यों हम यहाँ से आगे कर सकते हैं या नहीं? चलिए हम ये करते हैं पहले. Let us take this. Minus st plus at dt. Infinity e raised to t कॉमन निकाला, a minus s dt. Yes or no?
Yes, ma'am.
If I take the integration,
Yes, ma'am.
will this be the integration
Yes ma'am.
between 0 to infinity? Yes. Okay. Now I am substituting in place of t infinity. 1 upon a minus s constant है, बाहर ले लिया. e raised to infinity minus e raised to 0. Anybody can tell me what is the value of this? इसकी वैल्यू क्या होगी?
1.
e raised to infinity का वैल्यू -1
0
e raised to infinity 0 है
इंफिनिटी है
infinity आता है
मैम infinity क्या है?
हाँ,
1 by e raised to infinity 0.
and what is the value of infinity -1
infinity
इंफिनिटी
Infinity.
infinity into this constant
infinity
Infinity.
तो ऐसा कभी पॉसिबल है is this possible
No.
no it is not possible okay can you say this condition
Yes, ma'am.
if s is greater than a है ना s must be greater than a तो a minus s possible होगा
No, ma'am. Negative आएगा.
ये कंडीशन के लिए हमने यहाँ पे नेगेटिव साइन निकाली है कॉमन they have given this condition now if I take out minus sign common अगर infinity जब भी लिमिट है तो e का पावर नेगेटिव बनाना है make the power of e as negative okay so हमने क्या किया from here minus st plus 80 माइनस कॉमन निकाला मैंने इसे बना दिया नाउ इफ यू सब्स्टिट्यूट द लिमिट अगर अब इंटीग्रेशन करके इफ यू टेक द इंटीग्रेशन e रेज टू माइनस s माइनस a अपॉन माइनस s माइनस a ठीक है ना एंड देन इफ यू सब्स्टिट्यूट द लिमिट 0 टू इंफिनिटी क्या बनेगा ये देखो e रेज टू माइनस इंफिनिटी yes or no minus e raised to 0 fine अब बताओ मुझे e raised to minus infinity का आंसर क्या
0.
0 this is e raised to minus infinity 1 upon e raised to infinity 1 upon infinity and 0 ये बन गया 0 -1 so minus and this minus gives you plus 1 upon s minus a s is greater than a है ना अगर s अपने a ले लिया if you take s as a तो a minus a 0 1 upon 0 infinity बन जाता है which is not possible that's why this condition must be there understood so this is the way you can find the Laplace of e raised to 80 so if I ask you what is Laplace of e raised to 80 then what will be your answer आपका आंसर क्या होना चाहिए 1 upon s minus a ठीक है if I ask you what is Laplace of e raised to 2t बताइए आंसर
1 upon s minus 2.
s minus 2 Laplace of 2 e raised to 3t बताओ
2 upon s minus 3
1 upon s minus 3.
so क्या करोगे when this is there then linearity property the way you are using in differentiation and integration same way you can use linearity property in Laplace also okay take out this 2 aside then apply Laplace on e raised to 3t okay so 2 and what is Laplace of e raised to 3t
1 minus
upon s minus 3 this is the way you will do the questions or sums so ये linearity property यूज की है तो हमारी सबसे पहली प्रॉपर्टी linearity property है fine okay but if I ask you what is Laplace of e raised to minus 2t क्या आएगा आंसर
1 by s plus 2. 1 by s plus 2.
okay then what will be the formula for e raised to minus 80 Laplace of minus 80 क्या बनेगा फॉर्मूला
1 by s plus a.
हाँ तो बताने की जरूरत नहीं है so you know that this right so we have seen till now we have seen 3 formulas okay one first is Laplace of 1. Bolo. What is Laplace of 1?
1 by s.
1 by s. What is Laplace of e raised to at?
1 upon s
1 by
minus
s minus
S minus s.
Yeah. Laplace of e raised to minus at.
1
by
upon
s
s
plus
plus
s.
on a plus.
ठीक है ना, दोनों ही सेम है, ये पॉजिटिव है तो नेगेटिव साइड, ये नेगेटिव है तो ये पॉजिटिव साइड, ऐसे याद रखना है. 3 formulas done using definition of Laplace. Fine. Same like that, we can find Laplace of sine at, which is a upon s square plus a square. S is greater than 0 होना चाहिए. ठीक है. So now again, using the definition of Laplace, wherever there is ft, write down sine at. And you know very well, integration of e raised to at sine bt dt, integration का ये standard formula है ना? If you go on doing integration, अगर आप integration by parts करते हो, will it be ending process? Will this end the process? Integration by parts ये खत्म होगा? बताओ मुझे.
नो मैम,
No.
वो आगे और करना पड़ेगा.
अनएंडिंग इंटीग्रेशन होगा ये, है ना? हाँ, इसीलिए क्या किया है, ये फॉर्मूला बना दिया है. दिस इज द प्रूव्ड फॉर्मूला. ओके, who will tell me what is a over here? Compare with this and tell me what is a.
Minus s. Minus s.
A is minus s. Very good. What is b?
A.
Ma'am, a.
A. Fine. And then applied over here. फिर simplify किया है. And you are getting a upon s square plus s square. There is no proof can be asked in IMU exam. इसका कोई प्रूफ नहीं होता है. प्रूफ नहीं पूछता है कोई. Understood? But how we got Laplace of sin at? तो हमें पता होना चाहिए.
हम किसी का प्रूफ नहीं है.
नहीं, ये फॉर्मूला का प्रूफ नहीं है. बेसिक फंक्शंस के लाप्लास कैसे निकालते हैं वो प्रूफ नहीं पूछता है कोई. There are so many properties of Laplace, so ये प्रूफ नहीं पूछते हैं, लेकिन हम कर रहे हैं. ठीक है. What is Laplace of cos at? S upon s square plus a square. Okay. See this formula याद रखना है अब आपको. What will be my fourth formula? Laplace of sin at. क्या था? A upon s square plus a square. Laplace of cos at. S upon s square plus a square. If I ask you, what is Laplace of sin 2t? How will you write? What is the answer? Which formula will you use?
upon s.
2 upon s.
2 upon s square plus 4.
What is Laplace of 3 cos 90?
3 by s square minus 9.
You can take out 3 outside. अब बोलो. Cos 90.
3s by s square s by s square plus 9.
9 square.
Sorry, ma'am, 81. Sorry, ma'am.
Done?
Yes.
3s upon s square plus 81. So how to apply Laplace on this type of functions? ये आपको समझ में आ गया. So Laplace of cos 4t can be, Laplace of cos 80 is s upon s square plus a square. Same like that, Laplace of sine of hyperbolic of 80. I'll explain you this. We don't have a formula for this, ना? हमारे पास ऐसा फॉर्मूला है Laplace इंटीग्रेशन का for hyperbolic function. Do we have a formula like this? ऐसा है? नहीं है ना? We don't have. Okay. लेकिन if we don't have that, so we know the Euler's formula for sin h 80. Is it sine of hyperbolic of 80? बताया था ना मैंने फर्स्ट सेम में?
मैम बताया था.
हाँ, sin of h t or theta, sin of h of theta, e raised to theta minus e raised to minus theta upon 2, है ना? ऐसा ही cos h t का h theta का था. What is the difference?
Addition.
बीच में प्लस, है ना? So this you know very well. तो जब भी, now remember, हाँ, whenever you have hyperbolic function का लाप्लास तो यही यूज करना है. Why? Why to use this? Because you have Laplace for e raised to 80. Yes or no? Huh? You have Laplace for e raised to 80. Then you can apply Laplace over here. You can apply Laplace over here and then subtract it. Done with this. Understood? मैंने ऐसा बोला कि whenever, suppose आपको ऐसा पूछा, what is Laplace of sin h 2t? तो ठीक है, इसका तो फॉर्मूला है यहाँ पे, sin h 2t. You can use this formula directly. लेकिन sometimes this sin h theta or sin h 2t is multiplied with say sin e raised to 2t and sin h 2t. इसका लाप्लास पूछा है, तो क्या करोगे? Then convert this into Euler's form and then simplify and then apply. आपके पास जो फॉर्मूलास है उसका यूज करना है आपको. Are you getting me? जो फॉर्मूला है उसमें कन्वर्ट करना है, right? हाँ, let us see the answer for this. देखिए, e raised to minus st sin st का यूलर्स फॉर्मूला e raised to 80 minus e raised to minus 80 upon 2. Now multiply inside. ब्रैकेट मल्टीप्लिकेशन किया है. देखिए, ठीक है? Is it okay? Bracket multiplication e raised to minus st into e raised to 80. 1/2 बाहर ले लिया है. 1/2 is taken outside. Fine? ये स्टेप समझ में आया?
Yes.
Okay. And do you understand this?
Yes, ma'am.
Yes, ma'am.
है ना?
Yes, ma'am.
Okay. अगर ये नहीं करना है मुझे, सपोज, तो आप क्या करोगे? ये नहीं करना है मुझे, इसका इंटीग्रेशन करोगे, है ना? बट ऑलरेडी हमने इसका इंटीग्रेशन ऊपर करके रखा है ना, तो हम क्यों मेहनत करेंगे यहाँ पे? अंडरस्टूड? यस और नो? सो आई नो लाप्लास का डेफिनेशन, तो आई कैन राइट directly this is nothing but Laplace of e raised to 80, and Laplace of e raised to 80 is 1 upon s minus a. I know the result too. Number 2, e raised to 80 का मुझे रिजल्ट पता है. Yes or no? And e raised to minus 80 का भी रिजल्ट मुझे पता है. तो I have directly written this. यहाँ से डेफिनेशन लिखा मैंने लाप्लास का, एंड देन ये फॉर्मूला बना जो हमने फाइंड किया है वो लिखा है यहाँ पे. Fine. So substituting this formula and then I am simplifying, taking LCM and simplifying, you will be getting this answer. A upon a square minus a square. Same like that, if you find Laplace of cos hyperbolic of 80, क्या करोगे? What will be the change? यहाँ पे बीच में सिर्फ प्लस होगा, बीच में सिर्फ प्लस होगा. If you want to prove for cos h80, and then if you simplify, a कैंसल हो जाएगा LCM लेने के बाद, इसलिए s रहता है, तो s न्यूमरेटर में आएगा s अपॉन a स्क्वायर माइनस a स्क्वायर. फाइन?
Yes, ma'am.
तो इजी है cos h80 भी फाइंड करना. Okay. So, chaliye. How many formulas we have seen? First, Laplace of 1.
1 by s.
By
Laplace of e raised to at.
1 by s minus
1 by s minus a.
Laplace of e raised to minus at.
1 by s
plus a.
1 upon s plus a.
Laplace of, एक second, हाँ. Laplace of sin at.
a by s square plus s square. A minus x.
Upon s square
S
plus
square
minus a.
plus a square. ठीक है ना? Okay. Then Laplace of cos of at.
s by s square plus.
S upon s square plus a square. जब cos होता है तो न्यूमरेटर में s होता है. Denominator is same in both sin at and cos at. Understood? कैसे याद रखना है? Difference between these two formula. Okay. Now I want to write Laplace of sine of hyperbolic of at. Come on. What is the change?
In denominator minus.
It is s square minus a square. बाकी same है.
Yes, ma'am.
तो सिंपल ट्रिगोनोमेट्री में डिनोमिनेटर प्लस होता है बट हाइपरबोलिक ट्रिगोनोमेट्री में डिनोमिनेटर माइनस होता है. बाकी तो फॉर्मूला इज सेम. Laplace of cos of hyperbolic of at. चलो बोलो.
S upon s square minus a square.
S upon s square minus a square. Okay, ये सारे फॉर्मूलास बाय हार्ट हो जाएंगे नेक्स्ट लेक्चर तक.
Yes, ma'am. Yes,
अभी
ma'am.
हो गए हैं. अभी कितने याद है? You have to remember this formula, huh?
Yes, ma'am.
Yes, ma'am.
Same like that. If you go on proving Laplace for t raised to n, then you are going to get n factorial upon s raised to n plus 1 when n is integer 0, 1, 2, 3. जब n is integer होता है means t cube, t raised to 5, then you have to use this formula. N factorial means 3 factorial upon s raised to 3 plus 1. 3 factorial is 3 into 2 into 1 upon s raised to 4, which is 6 upon s raised to 4. Are you getting me? ये प्रूफ टेक्स्ट बुक में है. हम प्रूफ के पीछे अभी नहीं लगेंगे. Do you understand this?
Yes, ma'am.
How
Yes,
I
ma'am.
do that? But what if otherwise बोला है? If I want to find Laplace for t raised to half, बताओ. Which formula I should use? Gamma वाला. ये gamma n plus 1 upon s raised to n plus 1. I am going to use this formula. This is known as simple formula. This is हम इसे बोलेंगे gamma वाला formula. Gamma वाला formula कब use करोगे? If you have t का power negative और fraction, है ना? अगर इंटीजर है तो सिंपल वाला फॉर्मूला यूज करोगे. अंडरस्टूड? चलिए हम देखते हैं लाप्लास ऑफ टी रेज टू हाफ. ये कहां से आया? ये लिखा है ना यहाँ पे, ये फॉर्मूला, सम मोर फॉर्मूलाई. इट इज रिटन ओवर हियर. ओके, सो आई एम गोइंग टू फाइंड लाप्लास ऑफ टी रेज टू हाफ यूजिंग दिस फॉर्मूला. ये प्रूव किया हुआ है फॉर्मूला. इंटीग्रेशन डेफिनेशन यूज की है Laplace की, and this is proved formula. So what I will write over here? Gamma n. What is my n over here? 1 by 2. Gamma 1 by 2 plus 1 over s raised to 1 by 2 plus 1, which is equal to, we know very well, gamma n plus 1 कैसे लिखा जाता है उसे?
Half gamma.
n
n gamma n.
n, है ना? हाँ, सो हम क्या लिखेंगे? व्हाट इज माय n? हाफ. तो आई विल राइट हाफ comma half upon s raised to 1 by 2 plus 1 gives me 3 by 2. What is the value of gamma half? Root pi. And 1 upon 2 s raised to 3 by 2 root pi. Yes or no?
Yes, ma'am.
So for t raised to minus half, Laplace of t raised to minus half, Laplace of t raised to 3 by 2. For all this type of Laplace, you are going to use gamma wala formula. Okay? These are some standard formulas. जब हम properties करेंगे ना, तब आपको बताऊंगी मैं. This is multiplication by t property. Sin 80 मेरा original function है, cos 80 मेरा original function है. When I use original function or मेरा ये function, what does it mean? I know the Laplace of sin 80. I know the Laplace of cos 80. But I don't know the Laplace of t into sin 80 and t into cos 80. Multiplication में अगर दो function है, उसका Laplace हमने अभी तक देखा ही नहीं है ना? सिंगल देखा है. Laplace for क्या क्या है? एक ही function है. 1 e raised to 80, e raised to 80, sin 80, sin h 80, cos 80, cos h 80. इसके साथ दूसरा कोई function है multiplication में? No, you don't have. ठीक है ना? ये single ये है. लेकिन if there are two functions in a multiplication form, तो उसके लिए properties है Laplace की. वो हमें one by one we are going to see the property also. Okay? Now, using all these 9 or 7 or 8 formulas, we have to do some of the questions. Okay? तो सबसे पहले, what is the procedure? How to do the question? Okay? Mention the previous result which is used, like trigonometry, in a respective step, or convert expression into standard Laplace transform form. अगर आपको ऐसा दिया है sin x into cos x, इसका Laplace find करो. How will you find the Laplace? Do you have formula for sin x in cos x? Sorry, sin t cos t. चलो.
Sin 2t करेंगे.
Euler's.
Sin 2t करेंगे.
Sin 2t करोगे. Laplace of multiplying and dividing with 2. So 1 by 2 Laplace of sin 2t. Now you have this formula. Yes or no? देखो sin 80. A upon s square plus a square. What is a? 2. 2 upon, what is my answer? 1 by 2, 2 upon s square plus 4. Cancel हो गया, simplify करो. This is my answer. So what this step says? How to find the Laplace transform? कि use trigonometry or any result, use any result or any trigonometry. अगर logarithmic है, exponential है ना? तो simplify करो उसे सबसे पहले and convert it into standard Laplace function form. तो standard LT form में उसे convert करो. तो हमने क्या किया? We have used trigonometry over here. So we have converted it into standard form and then we are applying Laplace. Okay? State the properties or standard result of Laplace transform. बता दो कि हमने ये वाला use किया. Simplify for the final expression. Make it compact. Fine? ये linearity property है. Please see this property and tell me क्या है ये? What is this property? मैंने ये property आगे ऊपर use करके बताई क्या आपको?
Yes, ma'am.
Yes, यहीं पे भी use की है. देखो, I have used over here also. Linearity property. A जो है constant है, A, B, C. तो निकालो उसे साइड पे और फिर Laplace FT पे अप्लाई करो. Take outside and apply Laplace on the function. GT, HT, अलग अलग फंक्शन है. अगर आपको इसका Laplace फाइंड करने के लिए बोला, ये दिया है, तो you have to write L like this. Fine. लिखोगे ना साइड पे? ये तो फंक्शन दिया है. This is ft. तो you want to find Laplace of ft. तो आप साइड पे लिखोगे L e raised to 2t, ये ब्रैकेट लिखो. Then Laplace, apply Laplace on each and every function using linearity property. Okay. Next step कैसे लिखो बताओ? यहाँ पे कैसे अप्लाई करूं? How to write Laplace? 4 Laplace of t cube minus 2 Laplace sin 3t plus 3 Laplace of cos 3t. अंडरस्टूड? ये बता रही मैं. लीनियरिटी प्रॉपर्टी किससे बोलते हैं? आपने यहाँ पे लीनियरिटी प्रॉपर्टी यूज की. जो कांस्टेंट है उसे साइड पे निकालो एंड देन अप्लाई लाप्लास ऑन द फंक्शन. ये फंक्शन पे लाप्लास अप्लाई करो. अब व्हाट इज लाप्लास ऑफ e raised to 2t? कौन बताएगा मुझे? चलो जल्दी. किसको करना? 1 upon s minus 2 plus 4 t cube t raised to n is integer, n factorial upon s.
मैम 6 होगा. 6 by s to the power 4.
Yes. 4 into 3 factorial. पहले लाप्लास अप्लाई करो. s raised to 4 minus 2 लाप्लास ऑफ sin 3t. क्या है फॉर्मूला sin 80 का?
1 by s square plus a.
A upon s square plus a square. 2 into a. What is my a? 3.
मैम 3.
3 square. 9. 3. चलो बताओ. Cos 3t.
मैम s by s square plus 9.
minus a square.
Minus या plus?
Plus. मैम plus.
9. 3 स्क्वायर है ना. सिंपल ट्रिगोनोमेट्री है ये, तो नीचे प्लस आएगा. अगर हाइपरबोलिक है तो यहाँ पे माइनस आएगा. ऐसे याद रखो. देखिए करके बताया है. सो दिस इज द वे यू कैन अप्लाई लाप्लास. मैं ये पीडीएफ शेयर करूंगी अभी. 1 2 3 4 5 6 क्वेश्चंस आप खुद से करोगे. होमवर्क है ये. सॉल्व करके दे दिया है. Okay, same PDF I am sharing with you. I have already solved over here. देखो मैंने क्या लिखा है यहाँ पे. पहले लाप्लास अप्लाई किया, then मैंने linearity property यूज की, then I am using standard result, then I am simplifying, then I am compacting my answer. I am using gamma half का value root pi. Isn't it systematic?
Yes, ma'am.
अगर ऐसा करोगे तो बहुत ही इजीली आप काम कर पाते हैं. हाँ ठीक है. ये तो बहुत सिंपल क्वेश्चंस है. ऐसे तो क्वेश्चंस नहीं आते हैं. बट यस, हाउ टू अप्लाई लाप्लास. सो रिमेंबर ऑल दिस 5 क्वेश्चंस. सॉरी, ऑल द फॉर्मूलास, 9 फॉर्मूलास. एंड देन आई एम शेयरिंग दिस विथ यू. तो थोड़ा सा देखो, ये क्वेश्चंस भी दिए हैं. हाँ, हाइपरबोलिक के लिए आपने हाइपरबोला का फॉर्मूला यूज किया. ठीक है. देन cos 80 प्लस b. ऐसा तो हमारे पास फॉर्मूला नहीं है. वी तो है फॉर्मूला फॉर cos 80 ओनली प्लस b. ऐसा तो है नहीं हमारे पास. इज इट? देन व्हाट वी हैव डन. चलो नेक्स्ट लेक्चर में बात करते हैं. इट इज ऑलरेडी 4 o'clock. दैट्स इट फॉर टुडे. थैंक यू सो मच.
जय हिंद मैम.
जय हिंद. गजन सिंह सर अभी लेक्चर ले रहे हैं आपका? अच्छा, डिवीजन 2. अच्छा, शैल आई एडमिट हिम?
Yes, ma'am.
डिवीजन 6 यू कैन लीव एंड ज्वाइन सचिन सर का लेक्चर. आई एम एंडिंग द मीटिंग. I am ending the meeting. Huh? You are already co-host, Abhishek. Shall I end or leave the meeting?
Madam, you can make me host. I am Gajjan Singh.
Sir. Yes.
होस्ट बना दो मैडम है.
हाँ सर. हाउ आर यू सर? कैसे हो?
नॉट मच बैड मैडम.
ठीक है चलिए सर.
हाँ.
Good evening, sir.
हाँ, good evening, good evening. You can see the screen. I'm writing something. I wrote good. Could you read? Could you see?
Yes, sir.
You could see, na? Good evening. I'm writing good afternoon. Yeah. Yes, I'm just. Okay. Just take 1-2 minute break. I'm just preparing. Hai? Okay, madam was teaching you. Are you listening clearly? Na? Am I loud and clear?
Yes, sir.
Okay. I think I can start and I can give you a few minutes at the end. Will it be all right, cadets of us here? Will it be okay?
Yes, sir.
Okay. So I will, first thing I will tell you about myself. My name is Gajjan Singh. Okay. I just write down G-A-double-J. Age, I'm not able to write properly. G-A-double-J. Gajjan Singh, huh? Okay. This is Singh, G-A-double-J-N. So I was ETO on ship. Before that, I was working in the USA. And before that, I was in Indian Navy, okay? So the subject is power generation and distribution. Power generation and distribution. Okay, power generation and okay, this is a little mouse problem, but don't worry, I'll keep speaking more so that you can understand something. So there are two faculties. I'm the faculty judge and the RKS sir, who has been taking your class earlier. He is the faculty with me. So we two will be teaching you. Okay. So let us start with very, very basic things. It's a first lecture. It will be introductory part. I'll just tell you a very basic thing about electricity for today's lecture so that you can understand the topics at the later stage. Because if you don't have the basic concept, you will not understand much about the ship distribution and all. So once again, I'm asking you, am I loud and clear? Can cadet from the first year, can somebody speak out saying yes, loud and clear? Am I loud and clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. First, I'll tell you what is a line voltage. V line. Okay. In India, we have the 440 volt system. Okay. So please, maybe in your rough notebook, just write down V line, nothing much. So if somebody in future, if somebody is asking you, what is a line voltage? You say one phase, second phase, and third phase. Okay. So in India, we call red, yellow, blue. Okay. It is a phase and phase. It is a phase and phase. Red, yellow, blue. And it is always 440 volt. Okay. All electric motors, they run with the 440 volt. And now understood what is a line voltage? Phase and phase. Voltage between, if you put your multimeter at one phase R, and other end of the multimeter, if you put at the Y phase, your meter will read 440 volt. If you touch with one hand R phase, with the second phase, if you touch blue phase, you are going to be electrocuted by 440 volt. Japanese call RST. Okay. Japanese call RST. Understood? Indians RYB, Japanese RST. Americans call phase 1, phase 2, phase 3. If you go to USA, they call phase 1 PHA, phase 1, phase 2, and phase 3. And some books say L1, L2, L3. Matlab line 1, line 2, line 3. Line 1, line 2, and line 3. Now understood all the names? RYB, same thing. Japanese call RST. Americans and country, they call phase 1, phase 2, phase 3. And some books you will find L1, L2, L3. Can I believe you, all of you have understood what is a line voltage?
Sir.
हाँ बोलो.
Sir, RST का full form क्या है?
इसका बेटा full form नहीं है. अगर आप शिप में जाएं, आपको RST मिले तो इसका मतलब जापानीज है. Actually, RYB का भी कोई full form नहीं है, because it is a color.
Red, yellow, black नहीं सर होता
है.
Red, yellow, blue नहीं होती है. Full form ही
कलर यही रहेंगे. कलर तो ये इंटरनेशनली है. कलर एक वर्ल्ड में कहीं भी जाओ, रेड, येलो, ब्लू मतलब देखा तो अंडरस्टूड इट इज अ लाइन वोल्टेज है.
ओके सर.
कलर यही रहेंगे. कलर यूएसए में चले जाओगे, भले फेज 1, फेज 2, फेज 3 इज रिटन. In our college also, you will get RYB. Somewhere you will get RST in ship, our PVD. Phase 1, 2, 3, I think it's not, I didn't see, but it is there. Sometime you go to American, Canadian, what you call TK tankers and all. So phase 1, phase 2, phase 3, L1, in our workshop we have got L1, L2. So it's all line voltage. Huh? Is it clear now?
Yes, sir.
Okay. And again, I will tell you, it's a 440 and merchant ship also, generally 440. Whichever ship you go, generally 440 voltage line voltage. Now clear? 440. हमारा इंडिया का भी it is 440 and merchant ships are generally 440. If you visit the switchboard, merchant naval ship switchboard, you will write, you will see it is written 440 volt on the switchboard. That means one phase, second phase. So if you put your multimeter, there is a voltage of 440. So I believe that line voltage is very, very clear to you. Don't waste much, for my notes, no. just write down V line, then we will see. Just a V line. And then you in your mind, color should be RYB. Let it be RST, but color will be red, yellow, blue. Let it be Americans phase 1, phase 2, phase 3. Color will be red, yellow, blue. L1, L2, L3, color will be red, yellow, blue. So line voltage is very, very clear. Is it okay?
Yes, sir.
Okay, we will go to the phase voltage now. Just write down second word in your notebook. V phase. V phase. ऐसा लिखना है का. आप पढ़ रहे हैं ना जो मैं लिख रहा हूं, मैं सर्कल कर देता हूं. ऐसा सर्कल कर दिया. एक इसको लिखो and then you write the second word V phase. दो वर्ड हो गए, V line and V phase. Okay. तो V phase जो है ये हमारा डोमेस्टिक सप्लाई है. You know, in your home you have got TV, you have got a fan, you have got a tube rod, you have got a microwave, iron, कपड़ा press करना है, iron, and whatever you find in your home, your refrigerator, all run with phase voltage, not with line voltage. Single phase voltage. So can any cadet guess what could be the phase voltage?
120.
एक न्यूट्रल बेटा होता है, सब याद रखो, सब लोग याद रखो. चौथी वायर होती है, जैसे हमारे इंडिया में ऊपर वाली 3 वायर फेज होती है, सबसे नीचे वाली वायर न्यूट्रल होती है. ये नहीं भूलने का. और इसका इंटरनेशनली कलर जनरली ब्लैक है. न्यूट्रल एन लिखते हैं. आप समझ गए 4 वायर सिस्टम?
Yes, sir.
ओके. अब मुझे एक बात बताओ. सपोज यू वांट टू लाइट अप ए 220 वोल्ट लैंप out of top wire, second from top wire, third from top, and last wire, fourth one. Which 2 wire will you take for your lamp? This is the lamp. This is the symbol of lamp. Tell me, any cadet, 220 volt lamp, how will you light up?
So first and last.
Okay, first and last, yeah, second and last, yeah, third and last. Any one wire out of top 3 and neutral has to be taken. So it is the phase voltage. Clear? 220 volt. It is a 220. Or you can say 440 divided by root 3. Or you can say V line divided by root 3 is equal to VPH, V phase. तो आपको 2 अच्छी तरह चीजें क्लियर हो गई हैं. V line, V phase. So you will, I believe you will never forget these 2 words now. Line voltage, phase voltage. All cadets are listening now?
Yes.
Okay, please, those who are listening and understanding, help your friends to tell these things. Somebody might be having some net issue, some problem, but we have to learn the thing. Okay, this is electrical thing and you are basically mechanical. And I think you should take more interest because it's something new. This is an opportunity for you. So I think I'll move further now, considering you know very well line voltage and you know very well phase voltage. Thoda sa you bear with me, my mouse is giving me little trouble to write, but I will, next class I will get it all right. And just if you want, I can make a quick repeat what I have done up till now. I told you 3 phases. Names could be red, yellow, blue. Names could be RST for Japanese. Name could be phase 1, phase 2, phase 3. Name could be L1, L2, L3. It's all phases. It's a three wire system. If there is no neutral, it is a 3 wire system. Okay, 3 wire, 3 phase. 3 phase, 3 wire. Okay, and it is a generally 440. Russians are 380. Americans are 220 phase voltage. I'm talking about the line voltage. Russians are 380. Okay, but it's a country policy. It's up to country. We are 440. Okay, our country and merchant ships are 440. ठीक है, इसको रब कर दूं फिर मैं. Did you write 2 words V line, V phase in your notebooks? हाँ, तो 2 वर्ड ही लिखो. जब भी when you read V line, just your mind should scan red, yellow, blue, RST, L1, L2, L3, phase 1, phase 2, phase 3. It is a line voltage. It is between phase and phase. And then when you read phase voltage, just your mind should understand It is one phase and neutral. And it is our country domestic supply. So I'm going to rub this now. Now let us say,
Sir,
हाँ बोलो.
Sir, domestic और industrial supply में different है फिर कुछ?
नहीं, जब मैं word domestic बोलता हूँ, it is the light fan, microwave and all that, refrigerator. Domestic चीजें हैं जो घर में, ठीक है ना?
Yes, sir.
और इंडस्ट्री में जाओगे तो motors will run with 3-phase 440 and exact name will be 3-phase squirrel cage induction motor, that is a 440 volt motors. But in the industry, light and all that, it's run with the 220. You don't step down. Now I'm going to tell you third thing. Okay, if you have understood the phase voltage, if you have understood the line voltage, then next step I'm going to tell you now. Okay.
Okay, sir.
So let us say you are in the Tolani now. I am also here. I was on actually leave. That is the reason I did not take your class. But Maharashtra State Electricity Board gives us 22 kV. कितना? 22 kV kilovolt. मतलब 22,000 volt. They step, they make it somewhere. They step it up. And it comes to the primary winding of the transformer, which is very near to our workshop. When you come from workshop laundry side, when you walk from the main building and keep walking, keeping left side your workshop, and if you head towards laundry, just before, at the moment as the workshop ends, there is a transformer left side. So secondary is star configuration. I'm making winding. I'm making only secondary. Secondary, one winding, second winding, third winding. Secondary का 3 winding बना दिया मैंने. Can any cadet tell me how much is the angle difference? This angle
60.
120 बेटा, 120. पूरा सर्कल का 360 होता है, तो 360 divided by 3 is equal to 120 degree. 120 डिग्री का एंगल डिफरेंस, वो एंगल डिफरेंस ही 440 होता है. एंगल डिफरेंस ही वोल्टेज है, ठीक है ना? You know, one bird will sit down on one wire and he does not get shock. Angle at the left foot and angle at the right foot is same. So that's why he does not get shock. There is no voltage difference. Left, you see, when bird is sitting down on a top wire, his one foot is on one wire, say on the same wire, second foot is there, because there is no angle difference. Angle difference is with respect to second wire. He cannot touch the second wire. Okay. Now got it, no?
Yes, sir.
Okay. इधर से जो 3 लाइनें निकलेंगी ना, यही R/B है जो मैं अभी तक बता रहा था. ये 1, 2 and 3 देख लिया आपने? ठीक है, तीनों वायर देख लिया. ये ही लाइन वोल्टेज है जो मैं पढ़ाया था. कहां से निकलती है? स्टार कन्फिगरेशन. और दूसरा बात, डोंट थिंक अबाउट ट्रांसफार्मर नाउ. वर्ल्ड में जितने भी जनरेटर्स हैं, सबका स्टेटर वाइंडिंग भी स्टार कन्फिगर्ड होता है. तो अभी आपको ना समझ में नहीं आएगा थोड़ा. अभी जब कोई when we get the opportunity to visit ship and all, no, we will show you stator, we will show you winding. है फिर थोड़ा सा आइडिया मिल जाएगा what is what is a star configuration, delta and all that. है so अभी just remember state, जब हम जनरेटर बोलते हैं, it has got one stator, one rotor. So stator, I can believe it is difficult to understand at this moment because you have not seen the generator. But just whatever you can grasp, whatever you can get into your head, just try to understand, try to concentrate, try to listen properly, try to discuss, try to ask question. Don't worry, it is a first lecture, and never hesitate to ask even a silly question. If you very question of very, very minor nature comes in your mind, don't hesitate to what other cadets will think and all that. Just ask it because it's not your baby, it is electrical thing. maybe, we have done much work, and our when we speak, we may be at a little higher position, and you may not be getting it. So then you can by asking question, you can bring us to the level. So one phase, second phase, third phase है. और ये जो चौथी वायर थी ना, ये ब्लैक कलर का, एक सेकंड में कलर बदलता हूँ. वैसे ब्लैक चाहिए, देखता हूँ कौन सा कलर है. सेम आ गया, एक मिनट. ब्लैक किधर है? हाँ, मिल गया. ये ब्लैक कलर की वायर जो होती है ना, ये ही न्यूट्रल है. ठीक है. और आपने देख लिया नोड से निकल रहा है, न्यूट्रल नोड से. देख लिया सबने? हम स्टेप डाउन नहीं करते 230, याद रखना सब लोग. वी डू फॉर, if I ask one multiple choice, what you call that, objective type question. Okay, if I ask true false question, let me see how many cadets can reply. The voltage, the phase voltage 230, is it? Oh, okay, I'm making statement, so you will say true false. It is stepped down from 40. Is it true or false?
Can you repeat the question?
Question is this: line voltage is 440, phase voltage is 230. Is it stepped down?
Yes, true, sir.
नहीं, आप बोलो it is wrong. We just pick up one phase, one neutral. कोई step down नहीं किया, अपने आप 230 है. ठीक है.
अपने आप कैसे हो सकता है?
अपने आप मैं बता देता हूं, अगर आपको चाहिए तो मैं थोड़ा सा हिंट दे देता हूं. ये जो 3 फेजेस है ना, से 3, तो if one, अभी लंबी बातें नहीं बताऊंगा, आप कंफ्यूज हो जाओगे. 1 फेज, सेकंड फेज, थर्ड फेज. तो अगर ये 0 है तो certainly one is plus 120 and other is minus 120. तो ठीक है. तो ये जो minus 120 है ना, तो इसका पॉजिटिव इधर मिल जाता है. तो इसका जो इफेक्ट मिलता है ना, it is like two forces, equal forces lying at 60 degree. Okay, it is like two forces, equal forces lying at 60 degree, vectorly lying. Vector resultant will be like that. This one, vector resultant. So if it is a P, phase voltage P, so it will be P square plus P square and plus 2P square and cos 60 होता है 1/2 है.
Yes, sir.
1/2. तो अगर इसका पूरे का भी स्क्वायर रूट करने का, तो ये 2 से 2 जाएगा, तो पूरे का स्क्वायर रूट करेंगे तो क्या आएगा, बोलो ना.
√3p.
√3p. So naturally line voltage is equal to √3 into phase voltage. तो कोई स्टेप डाउन नहीं करना, भूलना नहीं है.
खुद ही कम होगी वो रिजल्टेंट फोर्स.
हाँ, इट इज, आप इतना ही याद रखो कि these are the, it is something like two equal forces which are lying 60 degree apart vectorally. So resultant will be √3 time more, which is line voltage. That is the line voltage. Okay. So this is the relationship. Line voltage divided by √3 is equal to phase voltage. Or other way you can remember like that. Phase voltage multiplied with √3 is equal to line voltage. कोई step down step up नहीं है. ठीक है. नहीं तो फिर कंट्री का तो नुकसान हो जाएगा ना. इतना ट्रांसफार्मर कहाँ से लाओगे? बहुत मिलियंस एंड मिलियंस पैसा चला जाएगा. कोई भी कंट्री ऐसा नहीं करता. ठीक है.
yes,
कोई भी कंट्रीज क्यों स्टेप डाउन करेगा? क्यों? एक गांव में 2 ट्रांसफार्मर है तो पहले तो 440 के लिए, देन 220 के लिए, तो बहुत नुकसान हो जाएगा. सो जस्ट फेज एंड न्यूट्रल. सो नाउ आई थिंक इट इज वेरी क्लियर टू यू, लाइन वोल्टेज एंड फेज वोल्टेज. सो 2 टर्म अच्छी तरह समझ में पता चल गया. और कहां से आता है, अभी ज्यादा ना लिखो, इतना ही लिखो, लाइन वोल्टेज एंड फेज वोल्टेज है. हो गया क्लियर?
yes, sir.
ओके. थोड़ा सा इसको, जहां इसको रब नहीं करता, 1 मिनट देखता हूं. ये जो एक चीज और याद रखना प्लीज है, आप सब नोट कर लो, नहीं तो तीसरा पॉइंट, दिस न्यूट्रल नोड, एवरी कंट्री इन द वर्ल्ड ऑन द शोर, नॉट इन द शिप, आई एम रिपीटिंग, एवरी कंट्री इन द वर्ल्ड, दे पुट देयर न्यूट्रल नोड आल्सो इन द ग्राउंड. इवन हमने भी तुलानी में ये किया हुआ है. जो ट्रांसफार्मर है ना, वहां से उसकी नोड से वायर निकाल के जमीन में खड्डा we have put up, you know, what you call we did dig out like 4, 5, 6 feet. What we made it moisturized and all that. We did put a rod and then we did connect the wire from the node. तो ये तो पांचवी वायर एक किस्म की हो गई है ना, ग्रीन वायर, ये इसको ग्राउंड वायर बोलते हैं। अब समझ गए 5 वायर कौन कौन सी? फेज, 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 ब्लैक, न्यूट्रल। हाँ, थोड़ा अमेरिकन लोग न्यूट्रल वाइट रखा, ये मेरी समझ में भी नहीं आया, बट जस्ट डोंट वरी, फॉरगेट अबाउट देम, बट जनरल कलर ऑफ न्यूट्रल इज ब्लैक है। एंड ये जो है ना ग्राउंड, इट इज ग्रीन है। पांचों कलर क्लियर हो गए?
Yes.
Third point, you can make just one word ground. Just write down. You wrote V phase. Sorry, you first wrote the V line, comma V phase, comma ground. तीसरा point ground. तो क्या मैं सिखाना चाहता हूँ about the ground? Can any cadet repeat what I want? What is my interest to tell you about ground?
सर कि वो नोड से निकाल के जमीन में डाल देते हैं वायर।
हाँ हाँ बिल्कुल, जो न्यूट्रल द नोड, even if it is a generator, no, even in our PVD there are 2 generators. So let the you know be generator running, let it be short supply. So neutral is, see, I'm repeating again, just pay attention. Neutral wire is also coming from there, which will go to the light, fan. It's a loop everywhere, like in your room, in your cabin. Neutral wire is coming to your fan. From there, it is looped to the light. From there, it is looped to third point. From there, it is looped to 3-pin, you know, socket. From there, it is going other room. In other room, fan, light everywhere. Then other room, then other hostel, then faculty area. Then, you know, neutral is everywhere without break. Neutral is, if you touch neutral, that means you are touching the node. Clear?
Yes, sir.
So you have understood 3 words by now. Line voltage, which is 440 for India, also merchant ships 440. You understood the phase voltage, which is 220, which is the phase and neutral. Got it? And then you have understood every country put their neutral into the ground. Then next step we will understand why it is done so. Why it is done. Why neutral is put into the ground. 3 पॉइंट हो गए क्लियर। ग्राउंड वर्ड जब पढ़ेंगे तो ये दिमाग में रखने का कि न्यूट्रल ऑफ एवरी ट्रांसफॉर्मर सेकेंडरी which is always star configured, it's always put in the ground. Should I move forward if you have understood 3 points? ओके, सीयर अपना नाम बताना, मैं कुछ पार्टिसिपेंट में जाके लिस्ट देखता हूँ। 34 लोग हैं।
064 अनिमेश।
एनिमेश मुझे आप अटेंडेंस बाद में दे देंगे?
यस सर।
ठीक है, मुझे व्हाट्सएप पे या ऐसे फोन पे या कैसे भी दे देना। एंड टेल ऑल कैडेट ट्राई टू बी प्रेजेंट है, नॉट टू बी एब्सेंट। यू आर फ्रेश यंग कैडेट्स, you come here to learn, and engineer person, they are never lazy. If somebody is lazy, he is not engineer. Okay, तो आपको lazy नहीं होना, थोड़ा active रहना and पढ़ना, take pain, take, you know, you have nothing you get without hard work and in simple word pain I mean not the frustration but happily reading है, mind is happy and you are doing your job. ओके, सो प्लीज डू दैट है। एक बार नाम बताना फिर div 2 का सीयर।
अनिमेश।
एनिमेश को मुझे देख लेने देना। क्या आईडी नंबर क्या है?
064।
हाँ, एनिमेश है, ठीक है।
yes,
तो हाँ ठीक है, अभी मैं नेक्स्ट स्टेप पढ़ाने जा रहा हूँ। इट इज दी, वी हैव ऑलरेडी डन लाइन वोल्टेज, वी फिनिश्ड अप विद द फेज वोल्टेज and you understood neutral, you understood the ground. तो मैं इसको 4 पॉइंट बोल देता हूँ, है ठीक है। न्यूट्रल भी समझ में आ गया कहाँ से आता है, नोड से, और ग्राउंड वायर भी कहां से आती है, आने का पॉइंट वही है. यू नो, इफ समबडी इज क्वेश्चनिंग यू, okay, नहीं तो I will tell you simple thing. I'll take your little test, small test. Okay, let me rub off this everything. Okay, I'm making the socket top point. Okay, ये सॉकेट होती है ना घर में.
Yes, sir.
हाँ, तो इसका मैं नाम भी दे देता हूं. ये फेज लेफ्ट साइड, ये पी ठीक नहीं लिखा गया बट इट इज ए फेज है, न्यूट्रल. एंड टॉप थोड़ा बड़ा पॉइंट होता है, बड़ी पिन होती है, ग्राउंड है. नाउ यू टेल मी, if you touch P and N, I should not use this word you touch. You should not touch electricity. Never do that. Never. Even while working also, try to work on the cold thing. Cold means switched off thing. Breaker must be off, supply must be off. Try to work when supply is not there. Only in emergency we do that. We can do because we are experienced. But to you, my advice is try to work after switching off, and even making sure that nobody should switch on when you are working. That also you should make sure. So you tell me, what is the voltage between phase and neutral? Kitna?
220.
Very good. It is 220. Now you tell me, what could be the voltage between phase and ground? थोड़ा टाइम ना वेस्ट करो. यू शुड टेल अर्ली सो दैट आई कैन टीच यू मोर. ओके, आई एम गिविंग यू हिंट. दिस इज द सेकेंडरी वाइंडिंग ऑफ ट्रांसफार्मर. दिस इज वन फेज. ओके, दिस इज द ब्रेकर, इट्स कमिंग हियर. इट इज द न्यूट्रल वायर कमिंग हियर. This is neutral also grounded. This ग्राउंड का सिंबल ये है. और आपका जो घर है, आपकी बिल्डिंग है, उधर भी एक ग्राउंड मिलेगा है. जैसे मेरी बिल्डिंग है, इधर मैं फैकल्टी एरिया में हूँ. जस्ट नेक फ्रंट टू माय बिल्डिंग देयर इज ए ग्राउंडिंग पिट. हम पिट बोलते हैं, ग्राउंडिंग पिट. ठीक है, और वहां से ग्रीन वायर ऐसे आ रही है. आप मुझे बताओ, ये चीज समझ लो, छोटा सा ये चीज, नहीं तो नोट कर लेना. ये पांचवी चीज हो जाएगी आपके लिए. सम बोलो. पी एंड है
0 सर.
नहीं, गलत बोल रहे हो.
220 होगा.
इट इज सेम. नो, यहां से ही तो आ रहा है वो भी ग्राउंड. इवन थोड़ा सा 1-2 वोल्ट ज्यादा होना चाहिए. सी, आई एम जस्ट मेकिंग दी, एक सेकंड देखो ना, ये तो मैं थोड़ा करो बना रहा हूं, लेकिन धरती में तो सीधा सीधा इधर आ जाएगा ना. ये आ गया ना, तो सेम चीज है ना. एन और जी में तो कोई फर्क नहीं, दोनों ही तो इधर से आ रहे हैं, नोड से. तो आप 0 क्यों बोल रहे हैं? नेक्स्ट अगेन, व्हाट इज द वोल्टेज बिटवीन पी एंड जी? ग्राउंड है. Come on, Dev 2 cadets, you should be very, very smart. It's a common sense question now. Why no reply from Dev 2?
220.
It is 220. डट के बोलो ना. Say loudly and clearly. Because it's the same thing, no? It's a neutral only. Only thing is that it is coming through ground. And neutral wire is coming through the proper wire, and G point is through the ground, so it is a better neutral wire. Okay, so now understood?
Yes, sir.
Okay, tell me what will be the voltage between N and G, neutral and ground?
So 0.
It is 0 because it's the same point, no? It's coming from the node only. Should be 0. Practically in workshop, when you get opportunity, we will tell you only 1-2 volts we get sometime. Then I will tell you why so. but theoretically it is a 0, because it is the same point, it is a node only, G भी node है, N भी node है, neutral node है. Got it all of you, Dev 2?
Yes, sir.
Yes, sir.
I think this made you little clear in your mind. See, I'm repeating again. This is electrical thing. Take more interest so that with your friend at your home, at least you can tell this is a 220. It is a phase and neutral. Ground ऐसा है थोड़ा ये सब चीजें. Then you can tell proudly. So should I move further now? If you have understood this much.
Yes, sir.
Okay. So please note down line voltage. You already wrote V line. It is a 440. It is phase and phase. It is red, yellow, blue in India generally. Phase 1, phase 2, 3 some countries. RST in some countries. And L1, L2, L3. Line 1, line 2, line 3. So phase voltage is one phase and neutral wire. हाँ ऐसा नहीं है शिप में न्यूट्रल वायर नहीं होता, मैं बाद में बताऊंगा. शिप में ओनली 3 फेज होते हैं, ठीक है. बट यू मस्ट अंडरस्टैंड फर्स्ट फ्रॉम द शोर व्हाट इज देयर ऑन द शोर. So we will not put up much time what is there, so that see why I am telling you these things. It is a related thing, no. If I teach you there is a neutral on shore, then I teach you there is no neutral, you will ask me a question, sir, why so? Then I will reply you and then you will understand properly. So next question, I'm just rubbing it off. You have, I'm just repeating what you have done. V line, V phase. You little understood about a neutral point and ground, and then you understood. हाँ इतना ही किया भी है, ठीक है. Next point, why ground? Can anybody, any cadet can tell me why grounding? हम ऐसा क्यों करते हैं? Why we are grounding?
सर जो मेटालिक अप्लायंसेस होते हैं उनमें चार्ज ले रहता है, एक्स्ट्रा चार्ज ग्राउंड में चले जाता है.
हाँ तो अभी मैं बताता हूँ, फिर कंपेयर करके बताना है. Let us take one generator. Let us take a secondary of transformer. This is the secondary of transformer. One winding at 120 degree, second winding, and at further 120 degree, third winding. Okay. Let us take one phase. Let us take breaker. This is a breaker है. You know what is a breaker? नहीं तो मैं फ्यूज बोल देता हूं. अगर ब्रेकर नहीं पता तो आज मैं ब्रेकर नहीं बताऊंगा. I'll tell you it is a fuse है. फ्यूज तो पता ना घर में. थोड़ा जल्दी ये सर.
Yes, sir.
ओके. तो फिर इसके बाद मैं दे देता हूं 3 पिन प्लग को दे देता हूं. बड़ी पिन, स्मॉल पिन एंड स्मॉल that socket या that small hole where pin is inserted. तो ऐसा फेज कनेक्ट हो गया. एंड आप मुझे बताओ ये न्यूट्रल वायर कहाँ जाएगा, जल्दी बोलो.
राइट में.
हाँ न्यूट्रल, ये न्यूट्रल हो गया और ये फेज. एंड यू टेल मी क्वेश्चन, ऑन शोर इज neutral grounded or not? Let us say true, false. On shore neutral is always grounded. Is it true or false?
True.
True. So I am grounding. जब ये ग्राउंड हो गया, लेट अस से आपकी बिल्डिंग के पास भी ग्राउंड है, तो वो ग्राउंड ये ग्राउंड सेम चीज है. तो वहां से ग्रीन वायर कहाँ आएगी, टॉप पे या नीचे, बोलो. टॉप पे. टॉप पे. तो ये ग्राउंड हो गया. ओके, लेट अस मेक वन आयरन. आयरन होता है ना, ये आयरन है, ऐसा शेप बना देता हूँ, शिप जैसा है. थोड़ा माउस प्रॉब्लम कर रहा है, जस्ट बियर विद मी. इससे लाइक आयरन कपड़े प्रेस करने में, इसके अंदर हीटिंग एलिमेंट होता है, पता है ना आपको.
Yes, sir.
एक मैं छोटा हीटिंग एलिमेंट बनाता हूँ. ये थोड़ा अच्छी तरह नहीं बन रहा, बट ठीक है, ये हीटिंग एलिमेंट हो गया है. ये इसके 2 पॉइंट हैं हीटिंग एलिमेंट के। अब मुझे ये बताओ, जो हीटिंग एलिमेंट के 2 पॉइंट हैं, which 2 wire will be going to this one out of P and G?
Phase or neutral?
Phase and neutral, very good. And generally it is a 220 volt. So is it true that phase neutral is 220?
Yes, sir.
Yes, sir.
ठीक है, तो इसको मैं लगा देता हूँ। न्यूट्रल को मैं एक जगह लगा देता हूँ। एसी सप्लाई है, कोई प्रॉब्लम नहीं है, उल्टा भी हो जाए, इसमें आयरन में उल्टा भी हो गया तो कोई बात नहीं। तो फेज कहाँ जाएगा? यहाँ पर। और यू मस्ट हैव वन 3 पिन प्लग, तो वहां से मैं ग्रीन लेता हूँ, 1 सेकंड, ग्रीन ये है, तो ग्रीन वायर जो है कहाँ जाएगा? बोलो अभी, बोलो कोई भी एक स्मार्ट लड़का, आई विल गिव यू फुल मार्क्स देन। बोलो कहाँ जाएगा ये?
सर नीचे
बॉडी मेटल पे जाएगा, मेटल पे, ठीक है ना?
यस सर,
मेटल पे, ठीक है। तो इफ देयर इज नो डिफेक्ट, तो ग्राउंड का कोई मतलब नहीं है। इफ नो डिफेक्ट, नाउ यू टेल मी, नियर टू फेज ये ग्राउंड कर गया। See, please, all of you, this is very, very important. I want some cadet should reply to me. Near to, due to bad insulation on heating element, ये मेटल को टच कर गया। अभी क्या होगा बोलो?
मेटल
शॉर्ट हो जाएगा, आयरन शॉर्ट हो जाएगी।
ये क्या करेगा? देखो मैं रूट बता रहा हूँ क्या होगा। कलर बदलता हूँ, 1 सेकंड है, ब्लू कलर लेके ना। ओके, तो जहां से टच किया देखो, फेज 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 ऐसा आएगा। हीटिंग एलिमेंट में नहीं जाएगा, उसका रेजिस्टेंस है, ये बॉडी से होके, ये ग्रीन पॉइंट से होके, ये जमीन से होके सीधा भाग के इधर आ जाएगा और न्यूट्रल पे आ जाएगा। तो बहुत हाई करंट फ्लो होके ये जो फ्यूज है, ऑब्लिक ब्रेकर है, अभी मैं ब्रेकर नहीं पढ़ाऊंगा आज, फ्यूज बोल देता हूँ। फ्यूज का वैसे ये ट्रिप हो जाएगा। सो नाउ यू हैव अंडरस्टूड द ब्यूटी ऑफ ग्राउंडिंग। अगर ये ग्राउंड नहीं होता या इसको ग्राउंड नहीं किया होता तो ये काम नहीं होता, ठीक है? बोथ साइड, दिस साइड वी कॉल बॉडी ग्राउंडिंग एंड दिस वी कॉल सोर्स ग्राउंडिंग। सो यू हैव अंडरस्टूड 2 ग्राउंडिंग, नॉट वाई ग्राउंड बाद में करते हैं, जहां पहले वाई ग्राउंडिंग समझ लो, फिर टाइप्स ऑफ ग्राउंडिंग में 2 ही ग्राउंडिंग पढ़ाऊंगा, सोर्स एंड बॉडी है। तो नाउ अंडरस्टूड व्हाट, व्हाई डू वी ग्राउंड?
यस सर,
ओके, चलो मैं एक और क्वेश्चन पूछता हूँ। सपोज ये ग्राउंड वायर नहीं होती, ये काटी होती, तो क्या होता?
करंट लगता सर।
अगर कोई आदमी टच करता ना, इफ यू डोंट टच इट्स ओके, हाँ, इफ यू डोंट टच इट्स ओके, बट सपोज लेट अस इट इज यू एंड आपने जमीन पे बैठे हो, टच कर दिया,
वो हमसे ग्राउंडिंग हो जाएगी।
फिर आपकी बॉडी से होके ऐसा करंट जाके न्यूट्रल में आ जाएगा, तो आप और सब सीरीज में आ जाओगे। थोड़ा सा हीटिंग एलिमेंट वेयर देयर इज द डिफेक्ट एंड दैट यू, एंड आपको बहुत शॉक लगेगा, ट्रिप फिर हो जाएगा, लेकिन झटका लग जाएगा, ठीक है? हाँ, फिर डेथ भी हो सकता है अगर वायर नहीं छूटे और ये रेटेड ब्रेकर नहीं है। रेटेड मतलब जब ब्रेकर है ही नहीं है, सपोज सुबह चोरी कर रहे हो फेज, so you are stealing one wire of the government and there is no tripping, तो ऐसा नहीं करने का। Now you understood what is the beauty of grounding? दोनों साइड ग्राउंड जरूरी है, सोर्स का पॉइंट भी ग्राउंड होना चाहिए एंड बॉडी को भी ग्राउंड करना बहुत जरूरी है। So can I believe you have understood line voltage? You have understood?
एक्सक्यूज मी सर।
हाँ बोलिए
सर फोन के चार्जर में तो सिर्फ 2 ही पॉइंट रहते हैं, तो फिर ग्राउंड कहाँ रहता है?
हाँ, वो
प्लास्टिक बॉडी होती है।
बहुत बच्चे क्वेश्चन पूछते हैं, उसको भी रहने दो थोड़ी देर के लिए, क्योंकि
सर कंडक्टिंग सरफेस नहीं है कोई।
आप मेरी शिक्षा पे चलो, शिप में, मर्चेंट शिप में या घर में, उसको मैं बाद में आपको, क्योंकि उसमें बहुत बड़ी फिलॉसफी है, मेरे को फिर आपको बहुत डीप जाना पड़ेगा, थोड़ा माउस ठीक काम नहीं कर रहा, थोड़ा आपको चाहिए तो मैं आइडिया दे देता हूँ, बट राइट नो आप इतना याद रखो, बॉडी ऑफ एनी इलेक्ट्रिक डिवाइस मतलब मेटेलिक बॉडी, दैट मीन्स एनक्लोजर मस्ट बी ग्राउंडेड। अभी इतना याद रखो, है?
यस सर, बाद में फिर पूछता हूं।
हाँ, आप ग्राउंड होना चाहिए, भले इवन इफ इट इज ए शिप, इवन इफ इट इज योर होम, ठीक है? जो भी इलेक्ट्रिकल अप्लायंसेस हैं उसका बॉडी तो ग्राउंड, जैसे यू सी योर रेफ्रिजरेटर इन योर होम एंड बॉडी ऑफ कंप्रेसर इट इज गुड इफ इट इज ग्राउंडेड है, या 3 पिन प्लग जो है ना मस्ट बी 3 पिन प्लग, नॉट वो तो फिर देखो सम कैडेट आस्क्ड मी 2 पिन, तो आप हर का ही ग्राउंड निकाल दो ना फिर, वो फिर यू नो दैट थिंग्स विल वर्क नो प्रॉब्लम. ओके okay, I can give you hint then. Okay, if you want little I will tell you. Let me check up time. Are you okay or tired? If you want I will give you break because you have to learn from other faculty again 4 to 5 and I don't want you to be tired.
Yes sir.
My work nature is that
थोड़ा सा बता दो.
You should be fresh when you learn things. Otherwise if you are not happy, your mind is not. So I will just teach you for 5 minutes and I'll give you. Yes, so I'll just I think give me a second. What should I within next 4 minutes? What I can do? Otherwise, you just remember this much only for today. Line voltage. I'll just ask question. Can anybody tell me what is line voltage?
440 volt.
Sir, it is R by B, RST, phase 1, phase 2,
Okay.
phase 3.
It is. You can say simple language. It is phase and phase. Voltage between phase and phase. Okay. It is line voltage. Okay, what is phase voltage?
Domestic voltage or DC.
You say phase and neutral. Okay, clear?
Yes.
How much it is? How much is the phase voltage in our country?
220 volts.
220. And how it is made? Is it step down?
No sir.
No, sir.
Okay, it is not step down, it is a neutral by ऐसे 220 हो जाता है. It is line voltage divided by √3. And थोड़ा एक और याद रखो, शिप में न्यूट्रल नहीं होता. This will discuss later on. Merchant ship or Coast Guard, Indian Navy and all that. I'll tell you later on. Neither it is grounded nor it is there. कोई न्यूट्रल से वायर निकालते ही नहीं है, ना ग्राउंड करते हैं. ये बाद में बताएंगे शिप में है. ठीक है, इसलिए जब डिस्ट्रीब्यूशन पढ़ाएंगे उस टाइम अच्छी तरह बता दूंगा कि वाई. तो ये भी हो गया न्यूट्रल ग्राउंड का. देन वाई ग्राउंड सेफ्टी. इसका आंसर है सेफ्टी. ठीक है, क्या आंसर है? सेफ्टी. शॉक नहीं लगेगा. एक्चुअली बेसिकली शॉक लगेगा पर ट्रिप हो जाएगा. ग्राउंड करने से शॉक तो लगेगा बट पर्सन इज गेटिंग अफेक्टेड विद द ड्यूरेशन, नॉट विद द इट्स अ ड्यूरेशन. So the moment you got electrocuted, immediately breaker will trip. तो ग्राउंड होने से इसलिए आपको कैबिन में शॉक लगता है क्योंकि न्यूट्रल ग्राउंडेड है और आपके पैर न्यूट्रल पे हैं. इसलिए the moment you touch a phase, you start shivering, you know, but a breaker trips. Now you understood why you get shock, because you are already sitting down on the neutral node. आपके पैर तो न्यूट्रल नोड पे बैठे हुए हैं. नहीं समझ रहे बातें?
आगे सर.
अच्छा, वेरी गुड वेरी गुड. तो ठीक है, फिर आप अभी नेक्स्ट क्लास किसका है? 5 बजे. यू वांट ब्रेक और शुड आई कंटिन्यू? सीआर कोई बात नहीं, आप बोलो, डोंट वरी. इफ यू वांट आई विल गिव यू ब्रेक सो दैट यू आर फ्रेश बाय 10 मिनट्स एंड यू कैन.
Yes, sir.
ये कोई वेटिंग रूम में कैसे आ गया? एक लड़का वेट है, कोई लड़का वेटिंग रूम में है, उसको प्रेजेंट लगा देना है. चलो ठीक है, यू कैन साइन ऑफ इफ यू वांट. लेट मी सी इफ सम फैकल्टी हैज कम इन, आई विल मेक हिम.
Sir, actually we have to go to snacks.
Go for
Now we are having break.
You want to log out or what you want to do? You want me to end the meeting? What do you want?
End the meeting.
End the meeting.
ठीक है, आप जा सकते हैं. मैं 2 मिनट में कुछ चेक करके एंड कर देता हूँ. हैं?
Okay,
Okay,
sir.
sir. Thank you, sir.
हाँ ठीक है.
Thank you, sir.
वेलकम all of you.
Thank you, sir.
हाँ, बाय.